My name's Bernard Lovett. I'm a volunteer at the Etruria Industrial Museum, which is the home of Jesse Shirley's bone and flint mill. It was built in 1857 to produce raw materials for the pottery industry. Many people forget that you can use clay, and you do use clay for pottery and glaze, but you have to add other materials to it. For instance, the local clays produce earthenware, which was used from before Roman times right into the 1700s and even today. But if you need to produce nice posh ware similar to the Chinese porcelain, and we call it bone china, or more properly English bone china, you need to take those clays, process the clays, and then add other things to it. Now here I have an example of the cup and saucer that is a local one. It's an Ainsley, but in fact it is nice ware. It's white, it's translucent, and it is easily decorated, and it's strong. To produce that sort of ware, you start with a clay, a white clay from Cornwall. The red clays around here are not suitable, but the white clays from Cornwall, which are similar to this, are very suitable. But on its own, it does not produce a good ware. So you need to add flint. Originally it was done, now it's different materials, but still additives. Flint, which is extremely hard, and also later to produce that ware, bone. Originally it was more like a stoneware with the white clays and the flint. Now here we are specialist bone and flint grinders. The big companies such as Wedgwoods and Spodewood have their own plants. So we are not posh, we don't produce nice posh ware, we're the dirty people. We process the raw materials to sell on to the potters, and they would then mix it with the clay to their own formulas. To give you some idea, English bone china is 50% bone, 25% clay and 25% flint. So you can see most of the constituents are actually not clay, they are other materials which need processing. So we're going to walk around and I'll show you the processes. As you will see, we're at a canal side location, and many factories in the Georgian and the Victorian era were built by canals. Of course, some of the factories were here first. The canals were the railways and the roads of the 1700s. The reason is roads were very poor, railways weren't invented, and it was very important to get good communications to bring raw materials in to industrial areas and then to get the finished goods out. Of course, in the potteries we're producing fragile goods, and so it was important to have a nice smooth transport link. And though canal boats only travel at 4 miles an hour, they can carry many tens of tons, so it's a very efficient way of moving heavy goods. Flints came from not only the east coast and south coast of England, but the near continent, especially Normandy and Belgium. So it could be brought across to one of the south coast ports, up to Hull or Bristol or Liverpool, and then by canal boat down to here and be unloaded on our wharf. The first process after the flints were delivered by canal boat is to calcine them. That is to heat them up to about 1000 degrees for 8, 10, 12 hours, and then they change their nature. They soften and go whiter. This is a typical flint kiln that was used between 1857 and the 1930s. This is the calcining kiln. Flint would be brought in now, and there are two pans. The pan on the right we've left empty so visitors can see. The pan on the left we've actually put coal and flint in. It's not quite right because normally you would layer the flint with slack coal, but we've illustrated it for visitors. You'd start at the bottom, set fire to it, presumably wooden sticks, and then when it was already burning, build up the layers. The doors are wood at the moment, but they would have been bricked or probably steel. When it's full, you could close off the kiln, and then the hovel gives it the draft to get the temperature up, which would take probably 1 or 2 days. You then let it run for 10, 12, 14 hours, and then it would cool down for another few days, and then you could get the calcined material out through drawer holes at the bottom of these pans, which are accessed from the room next door. The drawer hole would be bricked up or covered by a metal plate while it was going ahead with the firing, but inside you can actually see there is a vent that allowed the kilnman to control the airflow through the kiln. So when it was done, it was a manual job to actually shovel the calcined flint from the drawer hole so it could be transported by hand up into the pan room for grinding. After calcining, the flint in that state was brought up to this room through a hatchway and would be loaded into a pan. Water would then be added, and paddles driven by the engine push large stones round, and it's a tumbling action that the stones cause to the flint in the water that grinds them to a fine paste. The stones are special material called chert, and so is the floor, because you have to use a material that if bits grind off, it doesn't spoil the wear. In fact, if you use a metal pan, you have to then run the slop through a magnet to take out any metal particles, otherwise it gives you black spots in your whiteware. After grinding in the room above, the flint in a slop form, or more accurately suspension, comes down through a launder or a chute into that wash tub. Now the wash tub is like a blender, just as if I make a cake, it's a bit lumpy when I've put the flour and eggs and milk together, so that smooths it all out and makes a homogeneous product. It is then run off into tanks we call arcs or settling arcs, and there it's allowed to settle, as you can see here. In the end of the arc is a plate with holes and wooden bungs in, so they're progressively removed from the top, take the water out, and then you finish with a thick slop which can then be shoveled into barrels and delivered to the customer. However, if the customer was a distance away, you wouldn't want to pay the canal man or the carter to actually transport water, so there were drying beds now lost the other side of the wall where it could be dried into a cake.